Hello, and welcome to this nQuery demonstration. In this demonstration, we will show how to do a sample size calculation for the two-sample t-test using nQuery. nQuery is a widely used and fully validated trial design platform with access to hundreds of individual power and sample size routines for a variety of different tests and designs, ranging from simple t-tests up to complex adaptive designs such as sample size re-estimation. The two-sample t-test is one of the most widely used statistical tests due to its robustness to both small sample sizes and to deviations from normality. To do a sample size calculation for the two-sample t-test in nQuery, we will first cover briefly how to do sample size calculations in nQuery generally. In nQuery, sample size calculations will occur in the spreadsheet in the top left-hand corner of nQuery when you open a new table. In nQuery, this spreadsheet consists of rows and columns, where each row is a required input for the sample size or power calculation, and each column corresponds to an individual calculation. In other words, the calculation in column 1 will be independent of the calculations in column 2, 3, and so on. In nQuery, it is made very obvious which inputs are required to do a sample size calculation for the selected test or design. In this case, we can see on the left-hand side, the following parameters are required to do a sample size calculation. The significance level, whether you're doing a one or two-sided test, the group 1 and group 2 means, the difference in means, the common standard deviation, the effect size, the power, and the sample size. In nQuery, rows that are in white are those which are inputs to the calculation, and rows which are on yellow are those for which you can calculate if you input all other required parameters. You will notice that as we select rows, the help window on the right-hand side will automatically update to give us a definition, some suggestions, and the acceptable entries that are allowed for a given row or parameter. So for example, when we select test significance level alpha, we're given the definition of alpha, which is the probability of a type 1 error, and that 0.05 is a frequent standard. However, in a sample size calculation, there are some parameters for which we will not know exactly what the correct value will be before we do the study. In those cases, we will need to make a meaningful guess for what we either expect to happen or what we would consider to be the minimally clinically relevant value for that effect size, for example. So the sample size calculation that we're going to do today is based on a sample size statement given by the authors of a paper evaluating cyclophosphamide for scleroderma lung disease that was published in the New England Journal of Medicine in 2006. In their example, they assumed that the minimum clinically relevant difference would be -9. They then assumed that the standard deviation in each group would be equal to 16, based on prior evidence. You will note that in nQuery, when we have entered the difference in means and the common standard deviation, the effect size will have been automatically calculated for you to be equal to 0.563. This standardized effect size is a method that allows you to compare the magnitude of the effect expected in your study adjusted for the level of uncertainty you have around your measure or effect size, and can help you compare effect sizes across a wide variety of different studies. You will also note that the group 1 and group 2 means have been left unspecified. In this table, these inputs are optional, as the difference in means could be calculated using these two parameters, but in this case was used directly by the authors. These authors wanted a 90% power for their study. The power is the probability of rejecting the null hypothesis when the specified alternative hypothesis is true. In other words, if the difference in means is actually exactly -9 or greater, and the standard deviation is equal to 16, then if we enter 90% power, that is equivalent to saying that we want a 90% chance that we will get a significant p-value given that that difference in means and common standard deviation are actually true. If we enter 90% power, we will then see that for this difference and this standard deviation, we would need 68 people per group to get 90% power. In other words, if we have 68 people per group, there's a 90% chance we'll get a significant p-value if the difference in mean is -9 and the common standard deviation is 16. In nQuery, we provide a number of additional tools that can allow you to summarize and explore your results further. For example, by default, below the main table is the output statement. This is a simple verbal summary of what has been said in this column. In other words, that a sample size of 68 in each group will have 90% power to detect a difference in means of -9, assuming that the common standard deviation is 16, using a two-group t-test with a 5% two-sided significance level. And there are options to edit this using this button here, or to copy to clipboard, or to print, with additional options available from the context menu. There's also a notes panel, which will allow you to make any notes that you may have on the current case. There are also plotting tools available to help you explore your results further. There's an automatic power versus sample size plot available from the toolbar by selecting the power versus sample size option here. This plot automatically sees what sample size would be required for powers ranging from approximately 50% up to powers of around 99%. In this case, we could see that for 50% power, we would need a sample size as low as 25, whereas for an extremely high power of 99%, we would need a sample size of around 127. You can also see approximately that the sample size around 90 would be between 62 and 71. We can also edit the titles or other elements of this plot from the edit menu in the top left-hand corner. If we want to do a more customized plot, we can use the Plot User Selected Rows option here in the task toolbar. This will open a separate menu where we will have the opportunity to plot any continuous input against any of the solvers or outputs available in this particular table. So for example, if we wanted to see what the effect of deviating from our original standard deviation of 16 would be on the sample size, we can select the common standard deviation as the x-axis option and the n per group or sample size per group as the y-axis option. In this case, let's see what the effect on sample size would be for standard deviations ranging from 10 to 20 in increments of 0.1. As you can see here, as the standard deviation increases, the required sample size will also increase, as we would expect, with a standard deviation of 20 requiring 105 per group, while a smaller standard deviation of 10 only requiring 27 per group. As for the previous plot, we can also edit elements of this plot from the edit menu here. We could also evaluate that same data using the Specify Multiple Factors tool, which is an easy way to input multiple different variations and scenarios in nQuery. So let's look at a simple case where we go from 10 to 12, 14, 16 to 18 to 20 for the standard deviation and set a power of 90%. This will then automatically give us those 6 scenarios in the main table as here. So that's how you do a sample size calculation for the 2-sample t-test using nQuery. To learn more, visit statsolves.com. Thank you for watching.